Hello and welcome to G Fun Facts Online. Today we're journeying to a world next door, a planet so similar to our own, it's called our twin, yet so different it's a vision of hell. After decades of neglect, humanity is racing back to Venus. The question is, why? Why return to a world with crushing pressures, lead-melting temperatures, and skies filled with sulfuric acid? The answer is simple. Venus is a cosmic crime scene, and by solving the mystery of its demise, we might just learn how to save ourselves. Imagine two planets, born in the same cosmic neighborhood, almost identical in size and weight. Both are rocky worlds, and for billions of years both might have harbored vast liquid water oceans. This was the story of Earth and Venus. But today, one planet teems with life, while the other is a furnace. Venus' surface roasts at a scorching 900 degrees Fahrenheit or 475 Celsius. Its atmosphere, almost 100 times thicker than Earth's, is a toxic soup of 96.5% carbon dioxide. The pressure on its surface is a crushing 92 times that of Earth's, equivalent to being a full kilometer beneath our oceans. So, what happened? What triggered the runaway greenhouse effect that transformed a potential paradise into Earth's evil twin? This isn't just an academic question. Venus is a laboratory for climate change, a stark warning of what can happen when a planet's climate spirals out of control. The space age actually began with a focus on Venus. In 1962, NASA's Mariner 2 was the first successful mission to another planet, confirming Venus' extreme heat. The Soviet Union made Venus its own, achieving incredible firsts. The Venera 4 probe entered its atmosphere in 1967. Venera 7 made the first soft landing on another world in 1970, and in 1975, Venera 9 sent back the first images from another planet's surface. The last major mission was NASA's Magellan in the early 90s, which gave us our best radar map of the planet. And then, silence. For nearly 3 decades, our attention shifted to Mars and the outer giants. But now, a new generation of explorers is gearing up to break that silence. So what do we hope to find? The primary goal is to understand that runaway greenhouse effect. By studying Venus' atmospheric history, we can refine our own climate models and better predict the long-term impacts of rising CO2 on Earth. We'll also search for evidence of Venus' lost oceans. Did they exist? If so, for how long? Finding proof of a once habitable Venus would dramatically change our understanding of how common life might be in the universe. Another major question is about geology. Venus is covered in volcanoes, more than any other planet in our solar system. Are any still active? Answering this would help explain its thick atmosphere. We'll also study unique features called tesserae, which might be ancient continents, giving us clues as to why Venus never developed plate tectonics like Earth. And then there's the most tantalizing question of all. Could life exist today? Not on the surface, but high in the clouds, about 30 to 40 miles up, where temperatures and pressures are surprisingly Earth-like. A controversial detection of phosphine gas in 2020, a gas often associated with life on Earth, has made this a very hot topic. Exploring Venus is one of the greatest engineering challenges imaginable. The surface heat melts lead and zinc. The pressure would crush a military submarine. The Soviet Venera lander survived for less than 2 hours. Any new lander will need to be part furnace, part deep-sea submersible, equipped with revolutionary heat-resistant electronics. The atmosphere itself is a nightmare, thick, opaque, and filled with corrosive sulfuric acid. This is why orbiters need powerful radar to see the surface. And getting data back is tough. The thick atmosphere interferes with radio signals, and since Venus rotates incredibly slowly, a lander would quickly lose its line of sight to Earth. Power is another issue. The dense clouds block almost all sunlight, so solar panels are useless on the surface. Despite these challenges, a new international fleet is preparing for launch. NASA is sending a dynamic duo. First, Veritas, an orbiter launching around 2031, will create a high-resolution 3D map of the entire planet, looking for active volcanoes and evidence of past water. Its partner, Da Vinci Plus, launching around 2029, will drop a probe through the atmosphere itself, tasting and analyzing the gases as it descends to unravel the planet's history. The European Space Agency's Envision mission, launching in the early 2030s, will take a holistic view, studying everything from Venus' core to its upper atmosphere to understand how its geology and climate are linked. India is also joining the race with SHUKRAYAAN1, an orbiter currently targeted for late 2024. It will carry a ground-penetrating radar, a first for Venus, to map the planet's subsurface. China has expressed interest in an incredibly ambitious mission to fly into the atmosphere, collect a sample, and return it to Earth. And it's not just governments. In a historic first, the private company Rocket Lab is sending a small probe, the Venus Lifefinder, as early as 2025. It will carry a single instrument to look for organic compounds in the clouds, a focused and fast-paced search for signs of life. This new race to Venus is about so much more than one planet. It's about understanding the fine line between a habitable world and a scorching hellscape. It's a chance to test our climate models in the most extreme environment we know. The secrets locked away beneath Venus' acid clouds could tell us about the formation of rocky planets everywhere, guiding our search for life beyond our solar system. As we prepare to return to our long-neglected twin, we're not just looking at another world. We are looking in a mirror that reflects a path Earth could have taken, and a future we must strive to avoid. Unveiling the secrets of Venus is essential to understanding and ultimately protecting the precious, fragile blue dot we call home. Thanks for listening to Fun Facts Online.